Hi, I'm Sean Tierney, and this video is the second group's third session of the 2019 workshops for Java and FRC. In this video, we add autonomous code to our robot repository. To work alongside this video, you need to have the following installed on your computer. 1. An active JDK, which you can get from the Oracle website. 2. Some version of Git. 3. A GitHub account. And 4. Visual Studio Code with the WPILib extension provided by FRC, along with the Java extension pack and the Git extension pack. The links for downloading these are down in the description, and I hope this video is useful to you. Let's get started. So we're going to start off with, I had just merged the encoder code we did last time, and now we're going to start off making some autonomous. So if everyone can go onto master and pull.
These kind of changes before you merge. Changes were overwritten.
Yeah, so you can get rid of your changes. Either stash them or discard them. Okay. So I'll make a new branch. Alright, so I've pushed that branch, I called it autonomous. So Ethan, you're going to have to pull first.
Don't think my thing actually worked, because I don't have your changes that you made earlier. So this is nothing here.
Here, save your robot.java and go into your changes. Like maybe you just accidentally deleted it and it's
Failed to save content of the file as newer.
here. Or compare.
Okay, yeah, there we go. Can I just like accept this?
Yeah.
Just put it in.
You can here.
Changes in the right. No. Just go revert to file contents. That's probably it. There we go.
Yeah.
8
Perfect.
minutes ago.
Alright. So now alright, everyone is on autonomous, right?
Mm-hmm. Yeah.
We can let's do it. So, we can first just all do the same thing, and only one of us will commit it. And let's go into our autonomous code. So in autonomous init, we can just comment out that code that they gave us. So first we're going to make it time-based, and for that we're going to need a timer. So in robot init we can make our timer object. That's a class that FRC provides. So we can define it outside of the method. Declare it outside the method and initialize it in robot init. And then in autonomous init, probably could have even initialized it over there, but in autonomous init, let's make sure that it is reset. And we can start it at the beginning of autonomous. So the timer.get method is what's going to give us the time on that timer in seconds. We can comment out the switch case statement in autonomous periodic and make our own code. So let's say we want it to drive forward for, let's say we want it to drive forward for 5 seconds. So just for fun, like without looking at my screen, let's just see if you can do that instruction. So timer.get gives seconds, not milliseconds. Okay. All right. So it's on my screen now, and if you want to look and check. Okay. And Ethan.get is a method, so it needs to be, let's use, yep. All right, looks good. So now let's say we want to, so that code makes sense, yeah. Simple, easy. So now let's say we want it to drive forward for 5 seconds. 5 seconds is a long time. You might want it like 2 seconds. Drive forward for 2 seconds. Use like arm1 for like half a second, and then drive backwards for 1 second. Got that?
What was the order?
So forwards for 2 seconds, then move its arm1 for half a second, and then backwards for 1 second. All right. So Caden, I see a problem with yours.
Probably is. I'm good at this logic.
So let's say your timer is at like 2.5.
Yeah.
Then that would go into that else statement on line 25, set drive base to 0.
5.
And then it would go to the if statement on line 29, and then the else statement on line 137. I guess that's fine in that case. I picked the wrong case, but the fact is there's probably some, since you like made them all separate if statements, there's probably some like
Okay.
resetting and jittering.
Okay, so put them all on the signal.
Yeah.
Okay, so that's
Oh, did I mess up? Yeah, I did. All right. Edward, you're pretty close. So you'll want your drive base to like stop before, as well as your arm.
For a second.
All right. Looks good, Ethan. Caden, I think your comparing sign is backwards.
Yep, you're right, it is.
Huh. Okay. Looks good. So now that we have our time-based autonomous code, like that's not very precise because we're not using motor values. So we already have the encoders coded into the drive base, so we should use them. So for instance, here. Wait a minute. The encoder.getDistance. I remember. There was some other setup we had to do for encoders. Let's get that out of the way first. Setting the distance per pulse. Yeah.
Doesn't it do like 1024 encoder ticks per revolution?
I think so. So something like 1,000. So if it's 1,024 encoder ticks per revolution, and here, you know what?
Divide and then multiply by 4.
Right. So we can assume that. I'm just gonna kind of cheat and look at some previous code. Let's see. Robot.net. What is it on 2019? Okay, let me look at this. Oh, come on. I guess we didn't use it in 2019. I'll go 2018 then. All right. Here's the drive base encoder. Come on. It's hard to find. Jeez. Well, whatever.
Would it possibly been in the drive base code?
Maybe. Right. Yeah, it is. Set distance per pulse. In fact, we can just put it in the drive base code. Yeah, you should do it too, since you're also doing the autonomous. Alright. Now that we have that code in there, we can do our right, so I guess that's in inches. So if we want it to move, let's say like, sure, just 36 inches, 3 feet. For the first one, okay. Alright. So now when we combine these, we sort of run into an issue. We can't just say, if it hasn't gone the distance, then drive, and else stop and start the timer, because this is a periodic function, and it'll just keep starting the timer. And then the next thing will never get to run. So we can say drive base. We can make ourselves like a state machine that tells it like if it needs to start or if the things are complete. So here we'll say, we can still say else. No, we don't want to go else stop, because then it'll keep running that code, won't it? So we'll just end this if statement here. We can make ourselves a Boolean. Let's drive one complete. It started out as false. And then in this else statement, we can set that Boolean. Now we can have this dependent on the Boolean. Drive one complete. So if drive 1 complete and timer dot get, no, I'll just say if drive 1 complete, we'll start a timer. So that, make sure it's reset. And we can set our drive base to 0 and arm1 dot set rotator to 0.5 if that timer is less than, would we say, half a second. And then if that's not the case, if it's gone past that half a second, then we know it needs to finish the rest of it. So that means drive this for a certain amount of distance. So we can make another thing.
Would that always run since the timer never would be greater than that? Or that might be true since the timer hasn't been started.
Wait, it would eventually be greater than half a second, right? Because it has been started in drive 1 complete.
Yes, but before that.
Oh, okay, so would it be running? Yeah, we need to make sure it doesn't start in autonomous init. You're right. Good catch. If, alright, so where was I? We're making our Boolean arm complete. All right. So then else arm complete equals true. So then this next statement is going to be dependent on if the arm is indeed complete. Yeah, when we set this to arm complete to true, we can reset the encoders. And if arm1 complete and in fact we'll probably want a nested if for these last two, so we can include the drive base .drive 0 in it. So if arm complete, then we check if the encoders drive base.get distance is less than however long we want it to be backwards for. We can say like 18 inches. If it's less than that, then we'll this isn't good because we didn't check if drive 1 complete. I think this is a good format, this nested if situation, so I'm going to use that for our ARM code, because as it is now, it'll go to the else even when ARM complete isn't true before the ARM gets started. So guess my mom's back. Then we can say dang it, what was it? Alright, so if the timer is less than 0.5, then we want drive 0. Well, we'll probably want, if the timer is dang it, yeah. Yeah, that's why we need the separate boolean needs to start, because otherwise this line 132 to 135 will always run after drive 1 gets complete. So when you introduce these different components like this, it tends to get a bit complicated, and so I'm going to, once we do finally get this working, I'm going to introduce a system that Skyla came up with that's a lot easier to work with. So we can have, what do we need? An ARM needs to start.
You have the drive base part with an if an else if statement, it would run while the timer's still going though. You could do that.
What was that?
If the part where you just have the drive base drive right after the timer, if you have it in an else if statement instead of an if statement, it will run to be back to the beginning.
Okay, so on line 139, I have my like ARM1 set rotator, and then you mean I would change that else to an else if and start, or what?
Just since that part's a timer, it can still be done the same way it was before.
Okay, can you show me on your computer, actually? If you have it done so far?
Right here, it's the same way it was before with the timer. It only needs to be different when you're exiting into the point.
Okay. Right. If it's less than 1, and then inside if it's greater than 1. Oh, you probably shouldn't have your if statement on line 42 inside it, right? Because then that would never run. Well, but anyway, this isn't all that productive, like figuring out all the exactly how to do the state machine. So I'm just going to import in those import in those other files that I was talking about. Here, I should have it saved on my computer, so I can just open a Finder. I can go into my stuff, my 2018 FRC robot, and I can copy it from there. Okay. Oh, oops. Let me make sure it's in both. Let me fix all the package names. I'll just do that. All right. Alright, so now all the commands are fixed there. Let me then, oh yeah, I need to fix this stuff. Okay, oh shoot. Alright. Now those are green, and these, here, let me comment out this stuff. Come on now. So you kind of get the general gist of the state machine, even though we didn't finish it. So, if you look over onto my screen, here, let me just stage all of this stuff, except for the robot and the drive base. Added autonomous folder. And I'm going to do that. And I'm going to, here, I'm also going to commit add the set distance per pulse. Then I'll stash the rest. I'll get push. And now you can all see the other stuff. Okay, so how familiar are you all with interfaces in Java? As in like, an example of an interface is command.java, which is on my screen right now. It's this sort of thing.
That's where everything's abstract.
Right. So it defines it has methods in it that you would then implement an interface with a class, and you would use all of the methods that it gives you. So it's a way to define a bunch of classes as under one umbrella that you can then use to call anything of that type. So command interface is a class that can be run and reset, and that implements command. So on my screen, let's see, where do we begin? We can start off with some examples of these commands. Like there's the delay command. So it has the needs to start and the complete variables already in here. It creates an effective state machine that you can when you make the delay command, you give it a time, and then you can use the run method to actually run it. Pretty simple. Just does the timer stuff we've already done. And command factory is a very helpful class that provides methods that return commands. And so all of these methods can be overridden to take different sets of parameters, like if you have a drive command and all that, then we can do all that. Blah, that was barely English. So you have a drive command. Why didn't I put that sentence together? If you have a drive command, and you wanted to like give it a time or a distance or some like different amount of power on each motor, you can have a drive command with those different parameters. By overloading it, you can list the commands here, and now where it all comes together is the mission class, which creates an array list of commands. And this way you can have multiple missions, meaning multiple like sets of autonomous code that you could run in different matches under different circumstances. And it has multiple constructors, so you can even just give it command by command rather than making your own array list or list of commands. So that's pretty nice. It has its step field that it uses to iterate through the commands, and it makes sure that one command comes after the other. So it does all the state machine work for you, which is nice, so you don't have to think through that like accident-prone, bug-prone piece of work we just put together. Mission script, it's complicated, but it parses it, and like it's helpful, but we don't need to go over that now. So, and mission sendable, I'll go over that later. For now, we can work with the mission class, and we can make our own autonomous. So if you want to either stash your changes or comment them out, either one works. We can go into robot.
So these things would probably
That's because you're you have your changes that you haven't done anything with. So that's why you need to either stash them. Yeah. So you can like pull and then stash pop if you want to keep your changes that you made.
Different.
All right. Okay, so we can make our own missions here. Like we often have a do nothing mission if we don't want to do autonomous. Our drive forward mission. Okay. So the name's going to be used for displaying it on the smart dashboard. And for commands, we have command factory dot try. Oh, right. The forgot that all the other commands are in the other folder, autonomous 2019 or 2018. I'll copy that over as well. And I'll rename it to 2019. Now I'll fix all of the bugs that introduced. Oh, jeez, it's a lot of commands. Here. I'm gonna delete some of these that we wouldn't need. I'm going to delete this one. Okay. I might just go in here. Commands. Let's see. Command Factory 2018. Oops. So move intake command. We don't need that. We can. We'll want a move straight command and a move straight distance command. No move straight PID for now. Reset encoders is good. Rotate harvester. Don't want that. Set elevator. Set intake motor. We'll delete those. And then keep the rest. Okay. That's a lot of stuff to fix. Here, let's see if it Alright, there's that one fixed. Let me get rid of this heading code as well, because that would use a gyro. Might have even been better to just like make the commands on our own. That way we could like learn along the way. Okay. That's that code fixed. Move straight distance. We'll make this one on our own. Yeah. We delete for now, and we'll make it on our own. Reset encoders. I mean, I can just ignore a lot of those for now. It's kind of we really should have just like made it on our own. That would have been a lot. In fact, why not just do that, right? And then there. Let me sorry, this isn't a lot of stuff going on right now. Just trying to get it all set up. Autonomous 2019. Okay. Okay, clean slate. Autonomous 2019. That's nothing in it. We're going to make our drive forward command, so we can do that together. I'm going to make drive forward command.java. Alright, I'm going to copy over the timer command as a template. Come on now. Or the delay command. All right. Alright, should have made the folder commands. Now I'll see if I can put it in there. Okay. Name it drive forward command, and it implements command, that command interface, meaning it makes its own run method and reset method. We have that @override that you see sometimes with like subclasses when you override a method. That just makes it so the code breaks when it's supposed to. Like if we were to say @override and someone accidentally made it public void run, then it would break. Because that's not overwriting anything, only the Boolean is actually overwriting something. Anyway, so in its constructor, drive forward command. Let's see, what parameters would we want it to have? We would want it to have
I'm
a
supposed to
power.
have this file, because I don't have it.
Oh shoot.
I don't even have that folder.
You can make the folder. That's all. That's all you
Okay.
need to do. All right. By the way, did the command and mission system that I showed you somewhat make sense how it works?
Enough.
Enough that we can use it. It'll probably become more clear as we use it. Here, I'm just gonna open the 2018 one for reference. Okay.
Use what I have here all good. Make sure.
Let me see. Let me see.
Copy.
Yeah. Oh, it shouldn't be inside your autonomous folder. It should be just inside FRC.
Okay, so the autonomous turnout teach me inside FRC.
Yeah.
Okay, so we're going to use like this.
Cool.
Yes.
Now, so for a drive forward command, well, we'd want it to be able to drive backwards, so let's change it to move straight command for more clarity. Yep. Command, go. Come on. There we go. So we called this folder separately Autonomous 2018 because it would only be used for 2018. It's not as versatile as the general autonomous folder. So let's see. The constructor will be moved. Straight command. So for a time-based drive forward, the main ones you need are time and power. Power and time's probably a better order. We can have those as fields and as constructor parameters. Alright, so just like before, initialize our timer. We're also going to declare and initialize a drive base. In fact, let's see, we want to get the same drive base that we want to be pointed to the same drive base that we use anyway. So drive base, and we need that to point to our actual robot drive base object. And we can do that by passing it as a parameter. So this dot drive base equals drive base. I'm pretty sure that's how that works. Let me double check. And it is indeed how that works. Because object declarations are just pointers to, and the only way you can make a new object is to use the new keyword, which we're not using here because we've already initialized the object back in robot.java. We'll be passing it the object through command factory and into moveStraight command, so that this can then manipulate it. Does that make sense? Yeah, cool. So if it needs to start, the timer will reset, and then its start needs to start as false. And if it's complete, then we return true. Oh, that's right. There should also be a like a stop. We could also have like a stop parameter, like a Boolean stop. So that we can say if it stops afterwards. Oops. And then if it's complete, if it's complete, then we return true. But before we exit out of the method, we need to check if that stop condition is true. And if so, then we will set drive base to stop. And if it's not complete, then we are going to set the drive base to drive at the power that we got in the initial thing. MoveStraight command is now complete. Does that make sense how we use that? Okay. Okay, I'll move back to it.
So we're taking all that stuff.
Yeah, it's a lot. Makes sense.
Need to scroll back up a little bit.
Here, let me share just that screen. There you go.
Somehow I put a Boolean run as red. The method run of type MoveStraight command must override or implement a super type method.
Did he say? Oh, okay. Let me see. Oh, it's not. It should implement command. That's it.
Okay. Command. And it's red. I mean, I can copy result to type.
Import it.
This.
You haven't implemented reset.
Need to reset. Where? How do I do that?
That's down here.
Okay.
So that's why I was saying copy over the delay command from the autonomous, yeah, from the autonomous
Okay.
one.
Copy. All this stuff is in here.
Yeah.
So that makes it a lot easier.
Mm-hmm.
So maybe I don't actually have to balance it.
Right.
Where are you?
But you're probably like close enough that you can. It's probably easier to just continue down your path, right?
Yeah.
Rather than retype all the dry face specific stuff.
Yeah. So I'm just gonna do that there. Please, why is it like that?
We can always fix it on Thursday.
Yeah. Or faster.
Yep. I always like Flask. That's my go-to.
Hopefully that's right. There's no red, so.
Yep. Alright, so back in our... We're going to need to make our own command factory. Let me see. So, let's see. How do we normally do it? I think we tend to... What's it called? Extend the overall command base and then just have our own command base, or not command base, what is it called? Command factory. 2018 like that. Yeah, that's what I thought. Extends command factory. So we'll make our own inside commands, autonomous 2019 commands. Our own little folder. Command Factory 2019. Oh, not a folder. My bad. A file. Come on. Dang it. Okay. There we go. Not Java. Can have our package FRC dot autonomous 2019 dot commands. In fact, we can copy over our command factory in general as a template and alter it as needed. So autonomous 2019 is the package, and then we'll have command factory 2019 as the name, and it extends command factory. Alright, we're not going to have our delay. We will have our let me see. we'll have our public command drive forward, or not drive forward, what's it called? Move straight. Double time, double power. And Boolean stop. And we'll return our new move straight command. So this means we're making our move straight command object and immediately returning it. All right. Here we should have a constructor that gives it the drive base. So you only need to give it once. And we can make a drive base field that belongs to the class. So this dot drive base. You all know about this keyword, right?
Mm-hmm. Yes.
And return that so that we have this drive base and it's all good. So we have, let me see, we don't need our public command list commands because that's already defined. Nor do we need this import method. So really, that's all we need, right? Let me just double check. That's all. Okay. Let me check on your screens then. What's the issue it's saying, Caden?
That mismatch. Both in the straight command with command factory 2019.
Okay. Oh, yeah, because your type should be command, not command factory 2019.
This is right now. Command factory is up to type.
Gotta import it.
And we can go here again. No, we go from straight command to command.
Does move straight command implement command? Yeah,
Yes.
it does. Can you save it? Cannot convert from move straight command to command. Try exiting out and coming back in. That's worked the last 2 times. Something's been weird. Maybe? Yeah. Oh, VS Code. Is everyone else good? Yep, okay. Now let's use that back in.
Again.
Oh. Can I see your move straight command? Implements command. You have your reset method as well.
Reset, yep.
It doesn't move straight, by the way. You don't have your like drive base specific code in the run method, but that shouldn't be causing the problems. Right. I can go back. I can go back to it on my screen. There we go.
Yeah, that's way different. Can you scroll down a little bit just to make sure? Okay, that's it.
Okay. See if that fixes it.
Insert.
Probably doesn't, because I don't think that.
Break.
I don't think that would have broken it. Was there red on command factory?
Yeah, that's just we had supporting package the wrong thing.
Okay. Can you fix that? That might. It wouldn't be under. Oh. Interesting.
Yeah, it's in there.
Okay.
I put that in there by accident.
As long as it, yeah, that wouldn't break it.
Cause that,
Are any of you having a similar error? Any? Yeah.
Just pull yours at this point. You probably put probably missed something.
Your package should be in autonomous 19.news.
Right, but that's just that's where he put it, and that shouldn't cause the errors. There's some other like but what's the error in move straight command anyway? There's one inside move straight command.
Move straight.
Right.
Way at the top that I can't see. Oh, import. The clear package does not match the expected package.
You don't have a declared package. That's probably it, maybe?
Package FRC.
There it is.
And see in here. Save. Edit. Save. Nope. Restart it.
Yeah, we can just have me. Maybe.
Take a minute before. I think it's good. It's all green.
Okay.
Gray.
I think that would make sense if that one.
It
Okay. Well, yeah. I'm going to,
Stash.
I haven't pushed it yet.
Yeah.
There. I'm going to just have everything exactly as I have it right now. Okay. Here we go.
Okay, following track to be overwritten by merged. So I'm just gonna remove them. So commands, command factory merge break command. So delete. Merge break command. Delete. Alright.
Okay, so let's get this working. The command factory dot or command factory 2019 dot move. Oh, right. I should have initialized that in robot init. So command factory 2019. Oh yeah, since we have a command factory 2019 constructor, we can make an object of type command factory 2019. Just call it command factory, so we don't have to type a smudge or and all that. So now that's a new command factory 2019. Oh, because that's with the drive base that we're using for everything. So command factory 2019 dot move. Oh, right. We have to use the object, not the class, because it's not a static method. That makes sense. Move straight. Our time can be 0. Or no, what do we want? We want it like 2 seconds, half power. Stop true. And there we go. That's our first mission. And if we wanted more, we would just have to like all we really need is a few commands. We need that one. We need one for the arm, and we need if we want to do like the drive forward with distance. That way we can do all the different combinations of them. You don't have to worry about all that stuff. So we need to actually do it in autonomous periodic. I think I'm just gonna copy over some code because I think my brain is kind of done thinking by itself. Copy over some code from 2018. Here we are. Yeah, the trouble is this last year we didn't do autonomous, so this isn't like as fresh in my mind as it would be. Here we are, robot init, autonomous init, and autonomous periodic. So we only need, we don't need all that much to copy in here. So on my screen, you can see autonomous periodic. I'm going to copy this code onto here. And it uses an active mission, which I'll have to copy into existence. Okay. Active mission. So you don't have to copy all this with me, because since I'm just like copy pasting. Alright, so we have our well, we don't have to worry about our mission selector thing just yet. Just gonna try and, bless you, yeah. Try and make this work. Oh, you're not allergic to dogs, are you?
I'm allergic to a lot of stuff.
Okay. Because I have a dog, that's the problem. And she's very furry.
A little bit.
Yeah. We should have thought of that and, like, moved to a different house for this stuff. Sorry about that. Well, next time we'll be at the shop, so we'll just be allergic to the dust there, whatever. Alright, we have our mission, active mission, and we can set whichever one we want for that. And in autonomous periodic, if active mission dot run, then yeah, it'll just run it basically. So that's fully working code for autonomous. And if we wanted to make like a drive backward commit mission, we would really just have to, like if we wanted to make a drive forward and then drive backward mission, it'd be like super easy. I'm just going to call it mission 3 because I don't want to type much. And we're not going to actually use it. So we would have our move straight, then our delay. So hoping it would show up. Didn't show up. Okay. Command factory dot delay for like a second or whatever. and then command factory dot move straight for like 2 seconds, and yep, however you want to do it. And then like that's already another mission that we just made. So like once you get it set up, it's really nice to work with. All you have to do then is set active mission to mission 3. I'll show you in a little bit how to make it so that you don't have to change the code every time, and you can put it on a smart dashboard. Here. So we don't have a lot of time, but I think it would be nice to just have like a little break, at least for like for myself, because whatever reason my brain is just like threatening to shut off.
And then wait for you.
Yeah, possible.
So if you needed to do like the same one action, like lift up and use the angulator and put a cube on the scale, is there an easy way to make like that kind of a submission that you use repeatedly, or would you just copy over all of those commands?
If you wanted to, like, it'd be pretty easy, I think, just copy over the commands, but if you really wanted to, you could make a separate command that does all that. Yeah. So like in, here, let me share my entire screen. Oop. So over here, you can see in Autonomous 2018, we had like all of these commands that we made. It's like 10 commands. Like a lot of them are just like for each little mechanism we have something for it. Like once you get into the groove of making commands, just copying over the specific mechanism related parts of it, like it's pretty easy to make them.
And what if you needed one command to do like two things in a specific order? Would you have to make an escape mission within the command?
Let's see. You might want to just make 2 separate commands and just call them in that specific order.
Okay.
Like that'd be the easiest way. All right. Oh no, we didn't make any like cookies this time. That's too bad. We have some pizza if you want any. You want me to bring that out? Well, it's cold. We would have to warm it up. Yeah, sure. Why not? Go like 5 minutes before we get back in.
I was up until 3:30 last night and I'm just not feeling good. Because I was working on other things. And
What made you work up to 3:30?
I was working on my RC car.
That justifies it.
Yeah.
Yeah.
And I wanted to control it with Bluetooth with my Arduino.
I thought we had 3 pieces left, but I guess we only have 2. So you guys have to like fight over it.
Well, I had lunch, so you guys can have it. When you try to use Bluetooth 4 low energy on something that really isn't, like if you try to code it on a computer, it isn't designed to do that. On a computer, you're supposed to do it like on your phone. So it's so unsupported, and it just made me want to die. It was just hours of research and trial and error, basically. It's so weird the way that thing works. And by the end of it, it isn't designed to take commands as fast as I needed to send them, so even though it worked, it couldn't go
Delay.
fast enough. And there was some latency because there was so much code that had to run to send that command. So eventually I just bought the Bluetooth Classic module and left it at that. Yeah, well, I can use it for other things. It's not really designed to do that.
Hey, Mom. You're fine if I give them the rest of the pizza, right? Okay. Cool. All right. There. Oop. So how's everyone's summer been going?
Summer's over.
I mean, yeah. I mean, how has it been?
It's good. Just a couple
Oh,
months.
happy pie time. But anyway,
Got
continue.
it.
Anyone go anywhere? Do anything?
Went to Mexico. That was fun. I drove the car for the first time, so that was nice.
Wow.
Only a couple months away from my permit, so that's
Awesome.
nice. I'll throw it a lot.
Do you have like family in Mexico?
Just go down there for fun on the beach.
Cool. Yep. I went to California for my sister's baby shower, and earlier I went to Missouri for my grandparents' joint 80th birthday. It's not an 80th birthday where they smoke a joint. That's like that's a different sort of party.
My grandpa went to North Carolina, and I'm from North Carolina. And there's this restaurant there called Dockside, and they have heavenly crab cakes and key lime pie, and I would die for it. And my grandpa went up there to buy a new car,
Yeah.
so he went there and he took pictures of us and sent it to us, and I was like,
Oh, come on. Yeah.
I bought a Corvette. I was like 700 horsepower Corvette. It's like 70 something. Like,
I love a good key lime pie.
oh yeah. My dad hates it. I don't understand it.
Yeah, it just makes sense.
Just won't eat it.
I know some people who like hate chocolate. It's
I don't understand.
mm-mm. Well, I think that was a good break. Let's get back into it. Now, where were we? We made our do nothing mission and our drive forward mission. So the next thing to do is introduce the idea of a smart dashboard. So that's basically just a dashboard that comes up with the driver station on our driver station laptop, and we can put data on there, and we can use set data in the code. So we're going to use it to set the active mission in the code. That's why we made this variable instead of just having it call mission 3 or whatever mission we wanted it to. All right. Now, I can never remember smart dashboard code, so I'm going to cheat a little bit, look at my 2018 stuff. Luckily, it's all in that robot.java. All right. So this is where we're going to use our mission selector code. Let me revisit that. That's in, or not mission selector, mission sendable, under autonomous commands. No, not commands, just under autonomous. That's mission sendable.java. It has running, initialize, finish. It's part of the state machine. Let's see. It when you initialize it, you give it a name, and that would be displayed on the smart dashboard, and it's selected mission supplier. Now, a supplier, let me remind myself, so that's, okay. So it has, so it's something that returns a mission, basically. A class that has a get method that returns a mission. And in the run method, it does all the things that it needs to do. And that's pretty much it. We don't need to go into all of its intricacies. English is hard. Okay. Let's do maybe some copy pasting. So we have our mission sendable object we're going to make. We can make that as another field. So you all can do this with me. So we're going to initialize it in robot init, just like usual. Okay. No, that's not it. We don't want that one. Let's see. We want ourselves a sendable chooser. So, oh, the mission sendable, is that just used for? I'm wondering, is that just used for like our mission script mission and all right. So we have our like sendable chooser is definitely what we want. I really thought that's what we would be using, considering it was under autonomous rather than autonomous 2019. But okay, so I guess never mind mission sendable. We're going to be making sendable chooser. Yeah. Mission chooser. We can call it that. Okay, new sendable chooser, and it'll be choosing type mission. And then let's see, is there like an add method or yeah, add object. That's what we want. So we can have it as the do nothing. Wait a minute. Is this so the do nothing mission, this should all be declared as fields. Oh. Is that someone's parents? Hopefully that's not going to get it. Looks like it. Okay. So, yeah, up here I'm going to define these, declare these missions. And mission 3. All right. And now that those are declared outside of autonomous init, they should be accessible to robot init. So we can add object do nothing mission, and oh dang it, this should be do nothing mission dot get name and do nothing mission as the object, so that we have its name as the name and you're actually choosing the mission itself. Alright, mission chooser dot add object. We can have a drive forward mission dot get name and drive forward mission, and the same thing for the last one, mission 3. Just the inconsistency of those names is kind of funny to me. It's probably yellow because it's not used, right? Type safety. It's fine, probably. Okay. So active mission equals the mission chooser dot get selected. Bless you. And again, sorry. What's wrong? Returns selected option. If there is none selected, it will return the default. Oh, okay. So we need to make sure there is a default. And we can set the do nothing mission as that default. So when we worked with the do nothing mission, instead of add object, we'll use add default. Okay, cannot convert from object to mission. Okay, it's probably because when we define it, when we declare it, we should say sendable chooser type mission. That should fix it. Ah, gotcha. Now there is no error there. Does everyone have that?
Okay, that's fine.
Okay. You don't have a semicolon.
Yep.
But that's probably, oh, that is all.
Yes. It says there's more over here, but I don't see anything.
Oh, I see one. Line 151. That's one too many. Yeah.
Should be one more red.
Yeah, I see it. Line 128 and 129 semicolons.
How did you fix that error for mission chooser not get selected?
Yeah.
When you declare it, you need to say sendable chooser of type. Let's see, line 55. So sendable chooser of type mission. So using your greater than less than sort of things.
It's gonna be somewhere again. I'll have to send things like that. I can do an object to machine.
Yeah, that's your declaration should look like mine.
Oh, up there. Send the chooser. Okay, that's fine.
Okay. And so, Ethan, are you getting there?
Yeah.
Okay, so you'll need,
That doesn't work, right?
yeah, so when, yeah, you need your do nothing mission, right? Or is that what it's called? Here, can you go back to where you made your missions? Okay, so you declared it there. That's good. Can you go to where you initialize them? All right. Mission do nothing. All right. So if you have your drive straight command, you can do command factory. Did you make a command factory? Oh, well, you should have, did you pull like my latest code that when we were doing that? That somewhere in there should be like a command factory object somewhere in your Okay. Well, you can make one where you make all your fields. You can have another field of type command factory 2019 called command factory. Ah, so you already did that. Okay. You just called it command factory 2019. That's good. So you just need to make sure you have a lowercase c at that point so that you're referring to the object, not the... And that's weird that it doesn't offer you like the methods. It just offers you like the words. Like something must not quite be set up right. Because like it offers you guys like the methods with all the parameters, right? When you ask it for autocomplete.
Yes.
Weird. Anyway. So whatever your name is for Command Factory 2019, you can like peek into there peek into Command Factory 2019 to see what your parameters are and all that. Yeah, so like, here we go. Yep, you drive straight with all your stuff. And can you go down to your there we
This
go.
I got
Okay, so your line 111, shouldn't you have your parameters? Like, I don't remember the order that you did them in, but all right. And then when you're making your mission sendable, can you go back up to there? Or sendable chooser, yeah. So line 49, you'll need to make it sendable chooser of type mission. And then mission chooser, when it has the at object, you should have your do nothing.get name for your name and your do nothing as your, so it should have two parameters, a name and an object. So do nothing.get name and then comma do nothing. It is called do nothing and not do nothing mission, right? Okay. And you'll need parentheses for your get name. Okay, and same thing for drive straight. You'll want drive straight, not do nothing. And lastly, you want your add object on line 75 to be an add default, so that it never returns null, and it always returns the default if it's not selected. Alright, so now can you go down to where you set active chooser, or active mission? Yeah, that's perfect. Should be fine. Alright, good to go. Let's see. I'm trying to think, will we have enough time on Thursday to do everything that we want to do? So Thursday is the one at the shop. You all got the address, you know how to get there? Cool. I think that we should be fine just, well, it might be interesting if you guys could start working on making commands for your arms, so that we could use on Thursday. If you can each, like, I will make sure this branch is merged, and then if you can each like make your own branch, and each person makes 2 commands, one for their arm, one for their arms rotator and one for their arms extender. And it would be great if you could all at least try that by Thursday on your own. It doesn't have to work, because we can fix it on Thursday. It just needs to be started. So I'll do arm 1, arm 2, arm 3, and arm 4. And then we'll be good to go. Hey guys, thanks for watching. Hopefully this video is helpful to you, and I'll see you in the next one.